Yes.
Good evening, sir. Fine, sir.
Yeah, good evening. How are you?
Fine, sir.
So, how your project is going on? So today going to be have last class. So how things are going?
Um, it's okay, sir.
So project progress is okay.
Yes, sir.
I think they are planning to have progress meeting on Wednesday. Hope so. So
Okay.
we'll see. लेके चल जा ले इसको डिस्टर्ब कर जा Hello. Good evening, guys. Hello. Can you hear me?
Yes, sir. Yes, sir.
Okay. Good. So today is going to be last class for this advanced machine learning, whatever we were dealing with. So, so today I'm not going to start any new topic. So, so if you people have any doubt, you can ask. How many of you have completed that exercise classification image? What you call CNN classification? So, how many of you have completed? How many of you still pending?
Done, sir.
Yes, sir. Completed next day.
Completed. So, if you have any doubt, you can ask. So since it is last class, so it's good not to have any new topic. No? So already you know exactly how to run machine learning algorithm and also exposure of deep learning. At least you know how to create a network and then how to train CNN uh, and do classification. So if you want to also explore what will be next, then you can look for object detection. Okay. So next step of CNN is object detection. So in classification model, what we have learned so far, we need to have a image and image contain a specific object. Correct. Either the image contain dog image or image have cat image or that image have only one object present. But it may happen that in real time scenario that image contain so many objects. Correct. So that comes under object detection. So you can also explore if you want to pursue in deep learning something. So you can also see how this object detection works, and that is very interesting.
Hello.
Yeah.
Sir, I'm texted you 10 days back about the CNN case study. I was facing some problem.
So I will do one thing. Anyway, I am going to share the code with you people. Whatever code we have learned or discussed through class, that anyway once you get it, I think you can figure it out. Okay.
Yes, sir. That will
I
be
think that will
yes.
be fine. Otherwise, so many people has already completed it. So I
Yes, sir.
will share
No problem.
code. I will share anyway. I will share code,
Okay,
and
sir.
then I will also share PPT which I used to take to the class.
Yes,
So
sir.
that too, and then finally we are going to have one exam. I will talk with Himanshu exactly what will be the pattern, but mostly it is going to be modeling related task because the conceptual whatever we have learned, we need to know how to implement it, and that is important.
Yes, sir.
And that should be our objective actually. So if you get
Okay.
some data, you should know exactly how to get insight from the data and then how if modeling has to be done then how to model it, so that
Hmm.
has to be a goal actually.
Hello, sir.
I also got another message, let me check who has messaged me. Sajid, yes, You
Yes,
have
sir.
messaged me regarding outlay or something, no?
Yes, sir. So solved, sir. That problem I got.
Okay, so you have solved this. How did you solve that? So what was the
Uh,
problem
I
actually?
have, there were some outliers, so I have log transformed that. Then the problem was solved.
Okay. So how does log transform help you to resolve outliers?
Actually, there was outlier in salary. So there were some very big numbers, and some was very small.
So it,
So
it was
I have
it,
log
so
transformed it.
that made positively skewed, correct? That feature was
Yes, sir.
positively skewed, and then you just took log transformation. It worked.
Yes, sir.
So, but be careful whenever you do transformation. Na, be careful. Okay, because same way you have to transform when new data comes. Usually, what happens is people do transformation during training and then test also, because that time you have data set all together. But when you have actually to run for new data set, that time people do mistakes. So be careful actually. Whenever you have new data set, same way you have to transform your input and pass it to your model. Yes, Satendra.
Sir, I have a question.
Yes.
In our case study, now we have seen that we classified two images. Suppose if I have the images where multiple animals are there in single image,
Hmm.
then also this algorithm will work.
That's why I told na. So we have learned till now uh, up to image classification one, where you have a single image and that image contain only one type of species. Okay, means only one object. But in real time, what we can have is a frame contain multiple images, and what you are talking, correct? That comes
Okay,
under object detection.
okay,
So
okay,
object localization. So there is, you have to first go and localize the object and then detect it. So there is a two part here. Only what we were doing is we just had the image. We do transform image and then pass it to our deep neural network and classify it. There also
yes,
you have to use same thing actually. But
okay,
what you have to do is you can just think it like image. From a big image you have to get the what you call localized image or mini image, or you can say the cropped image. You just have to crop the pixel, different pixel, and pass it to your network. So that the way they have started the object detection problem. But after that they find that it takes lots of time to just do this thing. So there are new methodology come, something called YOLO detection technique, YOLO algorithm actually. So if you want to learn all this thing, CNN is going to be background actually, and on top of it there are some few more steps actually you have to do. Okay, so that comes
under
under object detection.
yes,
Okay,
And
sir.
that's why I told
So
actually, if you have this background, you don't stop it here. You just proceed further. And then also there, it's not there. This is up to CNN actually. And then there is something called time series analysis also. Okay. And see what, just think actually deep learning, whatever we were doing it in ML, na, all the things we are doing it in deep learning also. ML actually there is something called time series analysis. Same thing we are doing in deep learning also. There is something called PCA where we used to reduce dimension. Same thing we are doing in the deep learning also, with different names. That's all. But yes, some mathematics are tough to understand, but it is not too tough to do it. Try to understand and then try to implement it. Okay. Yes, Satendra.
Done, sir.
Okay.
Sir, do we have to learn OpenCV also for object detection?
Yes, good question actually. See, there are every time actually, if you see, there are new APIs come. So whatever you want to learn, you learn one, but learn it completely. See, something called fast AI, fast AI, I think. Fast API, fast AI also comes to do same task. You can use OCBS, that's also good. Kira you can use. Okay.
Okay, sir.
OpenCV is also very nice. You can also try it out. For object detection, people use it.
Sir, I have one doubt about ROC AUC metric.
Okay.
In one of the hackathon, they were supposed to calculate on this.
Okay. Yeah, there are these two are like key matrices to evaluate classification algorithm. Other than accuracy and then whatever confusion matrix we have learned, these are the two the more matrix we used it in classification actually. So how was your hackathon? Yeah, you were only asking na, oversampling, undersampling.
Yes, sir.
So how it went?
So it was good, sir. I got 917 out of 8,000.
Very good. So you got no.
Yes.
So I will make one slide and send it to you. Okay.
Sir, you are going to share all this presentation to us, where
Yes.
all the algorithms.
Yes. Whatever we have discussed in class, I'll share with you.
Okay. One more thing, sir. In my project, I discussed it earlier also with you. Because the training data is, sorry, the data entries are smaller, means they are only 70. So I'm not able to get good accuracy. It is up to only 67, 68%.
So what problem you are solving actually? Is it regression or classification? Regression.
And suggested me to do the correlation analysis. So I did
No.
that.
Okay.
I found a strong correlation between two parameters. So I removed one. So the accuracy improved a little bit, but not improved too much. Still it is 68, 69.
So which one you are solving classification or regression problem, na?
Regression.
Okay, 69 is okay, not bad actually. If it is real time data, then 69%. So do you make sure that you are talking about Q square, not R square. There are two metric, na? So which metric you are talking? How do you
Or
find accuracy?
accuracy, sir, I am calculating manually. Like I have the actual data point. If I am entering this similar kind of data, na, so I am evaluating that how accurately it is giving the output.
And
So
what does
it
it
should
mean? Similar data means what?
means the data which was occurred, which we have captured, which is used in the training data set.
Do one thing
If I,
actually. Do
yes, sir.
one thing actually. When you have a small data set, no, you cannot do train test split. Do leave one out cross validation.
Which one, sir?
Leave one out cross validation.
Okay.
Okay, so basically what it does is you don't have to split data, but same time what it's going to do is it will take n minus one. If you have n data point, it will take n minus one data point, and one data point it will left out for validation, and then it will move windows accordingly so that all data will be part of the modeling and all data will going to be part for the test data. Okay, so you will get R square as well as Q square. So same time you will get know that how your model is performed during the training on training data set, and then how model is performing on test data set. Okay, so these two metrics are
Okay.
very
Because I,
important.
as suggested, no, sir. You suggested me to try SVR. So I tried
Correct.
SVR also,
Yeah.
but
So
giving similar.
SPR also same thing. Leave one out. You have to.
Yeah. Okay. I will do that.
So what
Yes, sir.
it
Thank
will,
you.
what it does is, it will tell you exactly how this model are performing. See, and then you also get the another metric like what is the RMSC or absolute error. That type of metric also you can get. But important is R square and Q square. So like see, there are only few metric only you have to consider. If you are solving classification problem,
Mhm.
then you have to get what is the one is what is accuracy, but accuracy can be biased actually. Another thing is you can get the confusion matrix. If you get the confusion matrix, you will get whole picture of your model, exactly how it is doing. Then you have to
Okay.
get the ROC curve. Okay, it will tell you exactly how that model is actually performing. Eh, Okay, so
But
only few metric only you have to take care. Otherwise, things will work fine. If this key parameter you can find and then evaluate it properly, I think model will work. Okay.
Sir, computer vision comes under object detection.
Yes. See, I will tell you. So first it evolved with the CNN actually, and then where we'll have one object, and then an extension of this will be what it called object detection. Okay. In object detection, instead of one in one image, you will have multiple different object. See, I have created object PPT on object detection also. Those who are interested, I will share this also. So
Sure,
basically,
sir.
what is object detection? Exactly, if you have images, you can exactly identify with some probability or accuracy level exactly what object it is. Okay, so in one frame, you can have like different objective. In one picture, there are different objective, and then what are the different techniques we are using, what are the different algorithm we are using to solve this object detection problem. Okay,
Okay,
so
sir.
exactly how does it solve? and then last this is the what you call latest algorithm YOLO, and then there are family of YOLOs actually. It is not only one YOLO. Okay. So basically object detection first algorithm was this one, RCNN. And then after that the YOLO come. RCNN cannot use real-time detection. So YOLO come with this. So if you have heard about this uh, what you call driverless car,
Yes, sir.
so that uses same uh, YOLO algorithm to detect object present on the road when they have to change lane, when they have to put brake, accelerate, all this. So basically, this gives eyes to the driverless car. Okay, where the object is identify and accordingly it change their uh, positions. Okay, so I have this PPT also. Those who are interested can go through it.
Yes, sir. Please share, sir.
So those who are interested to learn this, they can. If they are interested to know something more also, they can also message me. If they have any problem after this also, they can ask me. Okay. So how did you find this class? Is it interesting or just like just
Very interesting. We learned
have
a
Very
lot.
So
interesting.
people
Very
learn
we
interesting.
have
anything?
learned a lot of things, sir. Thank you.
Many things we have learned.
Good. So I think someone had told in first class that I don't remember the exact wording, but
Satyendra,
I my response was I will teach him actually. I
Satyendra,
don't.
sir. Satyendra.
Who is Satyendra? Satyendra ji. So have you learned this time or not?
Learn.
Good. So that's our goal actually. So whatever you have learned or whatever you got this knowledge, you have to build up. This is just one step to learn data science, and data science is huge actually. And you cannot imagine where whichever places it's being implemented and researchers are going on actually. Problem which are not solved for like many years now, that is solved using data science. Okay.
Sir, can you
Can
please
you tell me which are the industry do you think data science is being used? Tell me few industries.
Data science, finance, people are using this insurance industry now, using data science,
E-commerce.
e-commerce.
Okay.
sir, health sector, manufacturing, every industry is using.
Okay.
Service sector.
Health sector, what they were using, where they were using data science. Can you tell me?
Sir, for example, I have seen on LinkedIn, one person has created one CNN model. Based on that, he's taking X-ray as a input, and he's identifying he is a corona patient or not.
Okay. Yeah,
So
that's
recently,
possible. That's possible.
yes,
For identifying the psychological state of person, uh, different uh, different methods can be used in data science.
Okay. What? Which other industry? Okay, apart from health industry. Okay, one is retail, another is health. Tell me other one. Manufacturing. Actually, you people have forgot it. Manufacturing.
Yes.
Yes, sir.
So, so the data science actually, what I think is now they actually each and every places they are utilizing data science. It is not about only healthcare, pharma, then manufacturing, all places actually. So actually, I have worked with so many manufacturing plants. So one was like Tata Steel, then Tata Motor, and all where we have used data science to solve their problem. On the Tata Motors, Tata Steels, and then Coromandel fertilizers. Then this one Coromandel ceramics. Which one? This ceramics. Who produce ceramics? I forgot. Carborundum Universal. That is also belong to Murugappa Group only. Even sugar plant, pharmaceutical. So I now actually I work with Pfizer. So Pfizer we are using data science to mimic basically their tablet manufacturing. So basically we are using data science to create virtual tablet. So how does it work? Basically, so if they want to produce any tablets, so what they have to do is first they have to create API, that is the original drugs, and APIs cannot give to any patient directly. Okay, API is active pharmaceutical ingredient. It maybe you have heard anywhere. So this is the API, but it cannot give directly to the any patients. So what they use to hold this API, they mix it with different excipients. So excipient hold this API, okay, and then they mix it and create tablet. And then when this tablets comes out, they have to go through different process so that it will not break during the processing. So tablets would have different properties like compression tablet has this much of tensile strength, this much of compression strength, all this actually. Okay, so that when it dissolve, it will come out, how much it will come out. So lots of things actually. So tablets should follow certain different properties set actually. Okay, so what we are doing is we are taking their historical data and then creating a model and saying that okay, if I know exactly what are the different ingredient you have mixed and what quantity of ingredient you have mixed to make a tablet, and if I know the properties of the individual compound, I can tell you what will be the tablet properties. Okay, and we are using machine learning algorithm. So if it's successful, then it's going to save lots of money because creating API is very difficult. Okay, one is you create API. If it's not success, you have to destroy it, and regulation are very strict. In India, I don't know how much, but US is in US now regulation is very strict. How to destroy all this API and all. So you cannot just it like you create it, do it. If not burning, just throw it. Lots of things you have to do. So better is you just produce whatever amount you want, and then use model to guide your reduce your experiment actually. So lots of interesting things. Another thing actually what we are working is like something called technology innovations. So basically it is totally stripped of manufacturing process. So now actually they were using batch manufacturing, but we are trying to convert into continuous operation manufacturing, and their data science is helping. So just think exactly at what level data science reached.
Sir,
So that,
just a hello.
yes, I'm listening.
Just a vague idea. Means if someone is working on virtual doctors,
Okay.
no, I want to ask you if there
Yes,
are some
yes.
developments in.
Why not? Yes, yes. See, and I don't think you need virtual doctor actually. You just create a database and then create some sorts of filter. They will prescribe exactly based on your symptoms, based on your age, based on your BMI, all this, what tablet you need. You don't need all the sophisticated one actually. And I think I
Yes.
have seen one doctor in Chennai. Just what he does, he just asks some sorts of question, he entered it, and then just printed out the description. That's all he had done.
Or
And
such
that's
doctors be on cloud also. Sir.
correct. So here you don't have to be very intelligent actually. For in medicine, see, in medicine, if you have a good database, then I think uh, your problem will be like resolved. You also find out actually the for more what you call most things actually the doctor prescribed same types of medicine always.
Yes. Yes.
So virtual doctor is easy task, but what I'm saying that what we are doing is that's something like it's going to uh, reduce scientist effort and then reduce material consumptions, reduce number of experiments. That's going to be tremendous. What you call it? They will just get lots of money out of it. And other thing is, yes, if you do less experiment, environment will also be clean.
Sir, in manufacturing also we are using digital replication of assets and processes, and that is called digital twin.
That is digital. See, I told you whatever we are doing, all these things same actually, and their digital teams in just a name, just a fancy name actually. After doing 10 years of data science, what people thought is will give one another fancy name, and that they called it digital twins. So what digital twins is doing is it just mimicking the process, and that only we are doing through data science. That's same we are doing. Na? We are also mimicking process. Correct. What we are doing for manufacturing, we are also mimicking process. We understand exactly how this casting process happened, and then we are mimicking that casting process. Correct. And that's called digital twins. That is another fancy name of the data science. See, we had neural network. People come with another fancy name. They called it a deep learning. But what next? What they have done? They have just created some layers of uh, another extra layer, and then bring some sophisticated algorithm to solve this problem. But if you see, code of this is nothing but neural network, correct? Same thing with digital twins. And it is not only database modeling. I'm saying that you can also think about hybrid modeling when you are talking about digital twins. Some part of the thing you can make it with first principle model. Some part of it you can make it with database model. Club both together, and then that will be your hybrid model. You call this as a digital twin. We also, when we give this fancy name, the customer will be very happy and pay more also. So we have given digital twins to what you call it, G. Same actually they have a problem with its smelter. So we have created a digital twin and sold it to G. So same database modeling, but yes, we have just put some part of first principle modeling. And what is first principle modeling? Nothing. Just we have used mass balance and then club with database modeling and gave it as a digital twin. Okay. So just think it is another some refinement of your database modeling or modeling part. I'm not saying database only, modeling part. And now it is very fancy, boss. So I have seen in Pfizer also, those people are also not talking digital twin and all. Same thing they are also doing.
Sir, can you brief something time series related?
I cannot hear you clearly, Rajni.
Sir, can you brief some on time series analysis, time series TSA?
Okay, you want me to explain time series analysis.
Yes, sir. Yes, sir.
Okay. If you want to really understand exactly what is time series, you have to understand what is random theory. Because time series is made on random theory. So it's good to know exactly what is stochastic processes and what is how do you characterize the noise present in the data, all this thing, and then what is ergodicity. So all this thing actually, but just think exactly. Time series is nothing but the sequential measured values where time and then measurement has to be in sequence. Okay, so basically you record a data at time t and then time t plus, sorry, you record a data at time t equal to 0 and then you start recording at time t plus what you call t plus t and so on. Okay, so basically your data now it is not random, it is on sequence. So this is the difference between time series data and the data ML data actually. Okay, so and there are different types of model and then they have named it like ARIMA model, AR model, MA model, ARIMA model, SARIMA model. Based on that characteristic of the data, you have to model it. I will, okay. So this is one part of time series. So what it's saying is, so just assume actually stock price, someone asks you to predict stock price. Okay, and you will have the exactly 5 years of data to predict stock price. But how do you know that which are the input influencing this? Because you are just seeing that response, correct? But do you can you quantify that? What are the things driving this market? Can you tell me? Correct. You don't know that. So how do you model it then? If you don't know input, how do you only know output actually? Basically behavior of market. Exactly it is how this is behaving over the time. But we don't know what is the input here. Correct. Then how do you model if you don't know the input? Then what people is saying that okay, some fictitious input is driving this market. That is nothing called E of k. That is a Gaussian noise. So you say that Gaussian process, a input which follows Gaussian process having mean zero and some standard deviation is driving this sorts of market behavior. Correct. And then we model is how that yk varies with the function of ek and then with the past of yk. Okay, so that model we call as a AR model. Okay, that is called the autoregressive model. Yk is equal to function of yk minus 1. So that is called AR model. Another model is MA model. So
So, AR model means ARIMA 1100.
AR means yes, ARIMA is general. Yes, you can say that. Yes, ARIMA is a general structure. You can say, or you can even call SARIMA actually if you want to call. You don't. There is another step where you have the seasonal behavior present in the data. Correct. So you are saying ARIMA, na? AR. Yes, 100 you can say, and 1 is nothing but your order. Okay. So this comes under time series data where you cannot quantify your input which drive your output. You don't know exactly how the system evolves. Okay, but there are another nature of data where uh, some part you can quantify, some part you cannot quantify it. Okay, so that comes under another what you call another field. They call it basically system identification, but that is also part of time series analysis. So basically, you can write initially how ARIMA model you have write y equal to some function of yk ek, correct? Yk minus 1 and ek. Here you have to write yk equal to function of uh, what you call the aq inverse by bq inverse uk plus. So basically yk had two components now. One is input which you can control, another input which you cannot control. There are two parts actually. One will come with the deterministic input. We call that, let's say, UK, which can be controlled. Another, we don't know exactly how this is coming. That is EK. So basically, you can just think that you have just now your output is influenced by two types of input. One is deterministic, another is stochastic input. That is also part of time series actually. Okay, so time series is also like a big ocean. So in my PhD, actually, I have worked 5 years on this time series analysis, signal design, all those things. And only after PhD in only one problem. Now also in Pfizer also we have solving another time series problem, but not exactly time series. So stochastic component we have just removed it and now it is like deterministic only.
Sir,
So very interesting actually if you want to understand time series, na. So the very so you can follow Arun book, Arun ke Thangirala book, but that it may happen that it will be difficult for you to understand, but you can ask me sometime. You can fix time with me and ask.
Sure, sir. Sure, sure. Sir, what I have understand ARIMA model. ARIMA 000 is a white noise model. ARIMA 010 is random walk model, and ARIMA X is just included uh, integrated moving average.
Correct.
So how?
Actually. So you don't have to be very confused actually. See, there are four parameters, that's all. And all are polynomial. P, Q, if I'm not wrong, one is P, another is Q, and two more
PDX,
actually.
PDQ,
Yeah,
PDQ,
P, Q, all those things, na? Correct. So these are
order.
all polynomial. And based on this, only your order will decide.
Yes, sir. Yes, sir.
Correct. And then if that have a seasonal component, then you have to do that frequency analysis or decompose your signal and get the frequency and use that in your model actually. Correct. That is Sarima model. Okay.
Order is
So
defined.
Arima is general. You can just think Arima is a general model based on your PQ PQ values. This model will define whether it will be R model, AR model, MA model. Correct. And
Yes,
how
sir.
to
Yes, sir.
get that what you call the order of this model, that you have to do either ACF or PACF analysis.
Yes, yes, sir.
Okay.
Even. Sir, what was the name of the book? Arun K. Thangirala.
Just find out. I think just go to IIT Madras and then get it book. If, I think I have copy of that book. If I get, I will send it to you.
Okay, sir. Do you have any material, I mean, PPT or anything? Can you please send me, sir?
I have it, but only caution is you cannot understand it. We didn't understand. Yes, it was didn't understand means yes, it took some time, but we have understood because anyway I graduated. I've completed in same field. I have done PhD actually. So I will find actually. I think I have his PPT also, but I have to find where it is. Someone has definitely shared with me, and I know so many people, so I can get PPT for you. But yes, you can try it out to understand. It's not too difficult. You will feel difficult when he talks about frequency analysis and all, but that is also manageable actually.
Okay.
Okay. So sometimes what happens is time domain you will not get information, but whenever you convert into frequency domain, you will see that how that signal behave, and then that's why people go from time to frequency and come back to time, or it may be frequency itself they do analysis. That's important. Okay. I will, but I will send it to you. Just send me message tomorrow sometime. I
Sure,
will
sir.
try
Sure.
to find it and then share with you.
Okay, sir. Sure, sir.
Good. Any more question? Any more question? No question. Good. So okay. Good luck. So you people also enjoy and then keep learning. That's important actually, and that's the message from my side.
Okay, sir. Thank you so much, sir.
Thank
If
you,
you
sir.
people have any doubt, you can contact me anyway. All of you have my WhatsApp number.
Yes, sir.
if you have people have any doubt, you can call me also. Saturday, Sunday, I usually free only, so I can help you out. And anyway, I will be part of your progress project meeting, progress meeting. So it may be some of you can work with me. So who has not completed anything in project, that guy can work with me. Okay. So
If
Sure, sir.
this is the case, then I would like to work with you, sir.
no, those who have not completed anything, you have to push him. Otherwise, you will say that I didn't learn anything. My motto is to teach each and every people, and I think if few people practice it, first it will be feel difficult, but I think after some time you people will confident. See, I have given you exactly enough background in CNN. If you want to explore more, you can go for object detection. You see exactly how does it work. It may be one time you will not understand the algorithm. You have to read 3 more times to understand it. But I think you can understand now. Okay, and try to solve what you call the real-time problem. That will be good actually. So now you have also had now you also have exposure of IoT now, so you know exactly how to tap your data. Once you get your data, you just do your machine learning. So now you have all tools to do and explore machine learning. Okay, boss. Any help you people need, you just let me know. I will share slides and I will share code. I will share Arun lecture with Rajnikant. All these three, I will send it to you people. Okay. Okay. Bye. Good night. Bye.
Good, sir.